Okay, so then this would be opposite -2, same 1. And it's a vertical parabola because it's a y equals an x squared. Down because of the -3 multiplier. So if this is my vertex, this is a normal pattern. What do you do with your normal pattern? Multiply by -3. So I'm going to go over 1 and down 3. Okay, so do you remember that from grade 11? So the range of this, the lowest would be -infinity to the top height of 1. Domain goes out, forever, ever. And then the axis of symmetry, do you remember what that is? That cutting line right through the middle. How do you make an up-down cut line? X equals, and which x value would it go right through? -2. Okay, so this is the new parabola. So this one has a y squared in it, an x. So do you see the difference? This one had a y in it and an x squared, and this one has an x and a y squared involved. So this would be a horizontal parabola. So the coordinate of my vertex would be, well, what's the new x value? -3, and the new y value, -1. When it's in this format, it's opposite, opposite. If you had that over there, it'd be opposite, same. And then this is a multiplier, a -2 multiplier, so it opens to the left because it's negative and it's horizontally negative, so left. So 1, 1, 2, 4, 3, 9, but I have to multiply by -2. And because this is horizontal, you're really switching your over-ups. So I'm going to go I'm going to go up 1, left 2. To be honest, what I do is I actually just turn my paper sideways and I just draw it like grade 11. I'm just like 1, down 2, 1, down 2. Does that make sense? It's just following the same pattern except for it's moving left that way instead of down that way. Okay, so the range would be -infinity to positive. And then the domain would be -infinity to the x value of -3. The axis of symmetry is now going to look like this. It's going to cut this way. Does that make sense? It's flat, so how do you make flat lines? Y equals, and what Y value does it go through? Okay, did you notice domain and range flipped positions from the first one as well, right? Okay, let's go to this page. Okay, who can identify the equation that is, bless you, that is the parabola from grade 10? So the regular vertical parabola, which one of those is it? The bottom one. Vertical parabola, because it's a y and an x squared. That's how I knew. There was a y involved and an x squared involved. Okay, so then which one is the new parabola, the horizontal parabola? The next from the bottom. And how did I identify it? Because there's an x and a y squared. Okay, which one is the circle? Let's do that one next. It's this one is the circle. And if I had it to identify it, it would be something x squared plus something y squareds. And it would have the same amount of x squareds as y squareds. So if you're ever identifying it, it would have the same amount of x squareds and y squareds. And a plus. And which one would be the ellipse then? The top one would be the ellipse. And the reason is I would have some kind of x squareds plus some kind of y squareds, but these would have to be different. So you're adding x squareds and y squareds for both circle and ellipse. They're both the adding, but one has the same and one has different. Okay, so these ones are hyperbolas because there's a subtract. Okay, those are hyperbolas because they're subtracts. So which way do they open? Okay, so this one has the y squared is positive, so it's going to go vertical. So how do I know? How can I identify it? There's a positive y squared, but a negative x squared. And then this one is going to be the horizontal. How can I identify it? Because there's a positive x squared but a negative y squared. Okay, so that's your formula sheet.
Okay.
These are the shapes. Okay, flip, flip. Let's match. Okay, so which formula has, oh, there's a subtract. So what do I already know? It's a hyperbola. Okay, it's a hyperbola because it's a subtract. So what do we get if we do x squared as the positive? Which direction are we going to do the hyperbola? Horizontal hyperbola. Okay, there's my number 6 is A. Okay, B, you have x. You don't have x squared. So what do you, it's a parabola, for sure it's a parabola. So which kind is it? Horizontal? Okay, this is a plus. And they're the same numbers. Same number of plus, then it is a circle. What does the next one, D? What does it mean when there's a subtract? Hyperbola. But there's a y squared to start positive, so it's a vertical hyperbola. You're going to add, but these numbers are different. So when you add, but they're different, it's a ellipse. And then the last one, if you had a y in it and just a y and an x squared, that's a vertical parabola. Okay, did you get C, E, F, B, D, A? Okay, here we go. Let's do one of each shape and then you're on your own. Okay, what kind of shape is number 1 here? There's a plus sign. Plus sign, different things, it's an ellipse. Number 2, there's a subtract sign. So it's a hyperbola. It's a horizontal. Number 3, there's an x, not an x squared, so it's for sure a parabola. And then what kind? Horizontal. And then the last one, do you recognize that one? It'd be a circle. Okay, number 1, we said it's an ellipse. So what is the center point? -1, +3. How much should I move left and right? Look under the X. X is moving left and right. So how much should I move? 4. And vertically I should move 5. Okay, you're not supposed to draw a point because the center is actually not on a circle. It's in the middle of a circle or an ellipse or whatever. And then you do 4 to the right of that. Okay, so you can see I went 4 left, 4 right, drew a point, 5 up, 5 down, drew a point. And then, good luck to you. Try to see if yours doesn't look like a potato like mine. Ooh, it's better, maybe.
Kind of looks like a football.
Hey. No judging. Do you want me to come over there and judge what yours looks like?
Probably
It looks
not.
like a circle.
Is that what we want?
No,
No.
you want
Holy.
what?
Looks like
Okay, I will not judge your oval shapes.
Peach.
Okay, number 2, can you get me the center? So the center is -3, +1. -3, +1, is that what you got?
How do you?
How did I get that? Is that what you said? Opposite that
yeah,
one,
okay.
opposite that one. Okay, underneath the X there's a 4, so that means X. It'll be 2, 2 to the sides. Underneath the Y is a 25, so that means up, down, 5. Okay, X marks the spot. There's my center. I'm going to go 2 to the right and mark an X. 2 to the left, mark an X, because these aren't necessarily on the graph. 1, 2, 3, 4, 5 up. Okay, your shape makes a box, and then your asymptotes will go through the corners and center of the box. Okay, so the box isn't part of your graph. Your box just kind of helps you line up your asymptotes. And now, which direction do we put this thing? We said horizontally opening, so it needs to have a vertex here. This is a point. And it needs to follow the asymptotes. Okay, number 3. So I don't have a center, but I have a vertex. So -2, +1. I went opposite, opposite. And then just a chart here, 1, 1, 2, 4, 3, 9. Does anybody know which direction I'm going to go? Because this is a horizontal parabola with a negative slope. I'm going to be going left. So, you know what I do? I actually just turn my paper sideways. And I just go 1, 3, 1, 3. There we go. If I turn my paper sideways, it's just like doing grade 11. Over, down, over, down. Does that confuse you?
Yeah.
Up. So then go up and left 3. Down and left 3. All right, last one was a circle. So then the center was +1, -2. +1, -2. And then the radius is 3. X marks the spot, center. Three, 3, 3, 3. And then, here it is, the perfect circle you've ever seen.
Boom. Oops, not me. Wow.
There you go.
Ooh, that was a brain buster.